This
now,
conference will now be recorded.
today I'm going to teach you Docker, right? So the
Mm-hmm.
first question, what is Docker? What is Docker? So if you ask me what is Docker, then I would say Docker is nothing but a container, okay, management, simple container management tool. Now we understand what is the tool means, or a platform also. So using this tool, uh, you can typically we use tools for what? Save time, right? Save cost, correct? Save and improve quality. These are the major reasons we use all the tools in the whole world, right? So here, save time in what context? Save time in what context? This we need to understand. So see, you have to remember that it's all about running app. That is a problem we are solving it. So where you were running app earlier? So you were running app in the
Server.
ser- physical servers, right? Physical servers.
Hmm.
Then we migrated where? You migrated to virtual server, correct?
Right. Hmm.
Virtual server means VMware, AWS, Azure, Google Cloud, and many more, right?
Hmm.
So you migrated to virtual server. Now the question is, someone will ask you, hey, why you are migrating? Simple, saving time, saving cost, and improve quality. What way? Saving time means, let's say here it used to take 1 day for setup of one server. Here 5 minutes, correct? No?
Hmm.
Here you have to spend a lot of money, let's say 100 grand. Example, just for visualization, okay? Here you are spending let's only 20. This means here it's not like utilization is less. Here your wastage is less. So your cost is also reduced. And when you
Right.
have everything on time and cost reduced, of course you will focus on the quality. So that's how. So now the question is where we are moving. So here, same way, Docker. This is the Docker which manage the container, okay, which will
Mm-hmm.
save time, cost, and improving the quality for running your app. So now if you run application in container, here used to take 5 minutes. Now 1 second you can run the application. How? Demo will tell you, right? Here saving cost again to the next level, maybe 5 or something. Okay. So that
Okay.
way some sort of optimization has been done in order to run applications in a container which can take less time, which can take less resources, ultimately help you to improve the quality. Okay,
Hmm.
so
Hmm.
simple. So if someone will ask you, hey, why we are using Docker or containers? Docker is not alone. Okay, so many tools for the containers are there, more than 10. Docker is a more popular one. For every domain which you have a 10 options, but I have included the only the popular one. So if
Hmm.
someone asks you why you are going for your container, you simply say we all are migrating to the cloud, software as a service. Everyone is in cloud. Look at the
Hmm.
uses of cloud. The cost is higher. Company do not want to spend so much of money for that. They want to reduce the cost. So they change the technology to run applications in data center. It's all about data center, not your laptop. Your laptop will remain same for next 10, 15 years also, by the way. It's all about the data center. Talk about the Facebook, Google, Amazon. They run your application, right?
Right.
LinkedIn.
Oh.
So it's all about them, right? And for that you have to learn, because Docker containers will not be used by a normal user, only developers, QA people. Why? Because they have to develop applications. They have to run their application for data centers, right? So that is how it is. So what is Docker? So Docker is a tool, simple, which will give you this benefit. But do what? Manage. Manage what? Container. Container is containing what? Container is your applications. Simple.
Okay.
Okay, so container is equal to your applications plus
Mm-hmm.
runtime environment. See, it has your app, it has a runtime environment, all two things together. Okay, so in a simple
Mm-hmm.
way, container is your runtime environment and which you run with the help of Docker. Okay, in a short, I'm stating it. Now, if you're really interested to know the architecture of container, this is a question
Mm-hmm.
mark I'm giving you. Assignment, let's say, assignment one here. How works. Container works. Why I'm giving you this assignment? Because you said you know Linux, and Linux has a kernel, and kernel knowledge will help you to understand this how container works.
Okay.
Okay,
Mm-hmm.
architecture of container. If you learn, it will be faster for you the moment you can understand. Okay, so every answer is
Okay.
hidden in the kernel itself. Okay,
Okay.
so that is how it is. Now next thing is, uh, so Docker is a container management tool. It manages the container. Container is where you have. Now let's say you want to learn Docker. So what are the things you need to have in your bucket? I call it components of Docker. Okay, which are the things? So take it very simple. Okay, simple approach. Forget about the container for some time. Think about the VM which you know from last 20 years, right? So
Mm-hmm.
what exactly the component of VM, right? VM. So first of
Mm-hmm.
all, you need to install the hypervisor. Hypervisor, correct?
Right. Huh.
Hypervisor means spelling mistake, I guess. Hypervisor means VMware
Hmm.
or VirtualBox kind of it, right? So
Oh,
you
it's
have to
manage the
install,
hardware and resources.
right? Correct.
Huh.
So you need to install hypervisor, and then you need to get an image of
Correct.
ISO image. Typically, OS image you get which has a OS plus app also there is there, right?
Hmm.
Correct.
Right.
And then you create a VM. Mind it, creating and running is a different thing. Create a VM and then run
Hmm.
the VM. Run a VM and stop the VM, start the VM, pause the VM, unpause the VM. These are all the things you do that, correct now?
Correct.
Yeah. So something similar Docker
Mm-hmm.
also has, but you need to understand this. Docker also has component of VM, right? Yeah. So what is the component of Docker? So here you have a Docker itself. That's we call it a Docker engine. It's a software I will install in few minutes in front of you. Okay. So we need
Mm-hmm.
a Docker, but here you need an image also. We call it a Docker image. There we call it a VM image. Here we call it a Docker image. Okay. Now you will
Hmm.
say what it contains Docker image. So here is a different. Here it contain. See here,
Hmm.
I'll tell you in with this one. When I say OS, and little bit of language then also. So here when you say OS means what? OS means kernel. Okay, and
Hmm.
then root file system. Root file
Correct.
system. Root this kernel is nothing but a boot file system basically,
Hmm.
right? Boot
Correct.
code, then root code, and on top of that many applications are there. Correct now?
Applications. Right.
Yeah. So here, but in this image, you know what? Understand this. You have in this image you don't have kernel actually. Mm. So if someone will ask you, hey,
Mm-hmm.
docker image, docker you use for container, do we have a operating system? You should say no. You should say
Okay.
no. So container, see, remember that containers come from what? Docker image, and
Mm-hmm.
docker image do not have operating system.
Operating system.
Yeah, but it has a root file system. Okay, root
Mm-hmm.
file system. So example for this it can be root file system Ubuntu plus Java, something like this. So now you'll say Ubuntu is operating system. No, Ubuntu is not operating system. Ubuntu is equal to Linux kernel plus root file system of Ubuntu. They have installed some software here. They use the Linux kernel and they installed something and they named it Ubuntu. Similar thing they have done on Red Hat also they did it. And any vendors which they have done it. Correct now?
Right.
So here I am talking about this one. So any image you will have a root file system. This
Hmm.
root file system can be Ubuntu, CentOS, Fedora, Debian, this that, and Linux kernel will be on base. I'll give you one image actually, simple one though, not complicating. See here. So this is your one physical server, and here you have a kernel. Okay, and
Hmm.
then kernel create a root file system. Correct, root
Hmm.
file system, and then create one more resources network,
Right.
one more resources bit tree,
Hmm.
and one user. User is like this: one user, two user, three user. See here. So this is the user is using the same PID. This user also using same PID. This user is using same PID. This user also same network, same network, same network. This user using same root file system. Root file system means like this. Okay, so they are using it. Now they this root file system using this all these resources come from where? All these resources because of this kernel. So so what is the difference between the virtual machine and kernel? So in the kernel, sorry, in container, what happens? Let me show you what happens. This is a kernel, okay? This is
Hmm.
the kernel, and kernel will create one root file system, one network, one PID, one user, one user, one PID, one network, one root file system. So this is like they are creating multiple resources here. See that? That's a different. This is the typical virtual machine. This is the typical virtual machine. This is the container. So here,
Okay. Means
this
in containerization, every user have all these component.
100% yes, sir, right.
Okay.
In a container world, every user will have their own resources, and these resources will not be shared by other user. So this one unit of this whole combination is called container. Simple.
Okay.
Got it. Now these containers come from where? Image. And image what you have, I said very clearly, root file system plus Ubuntu. So here you have a kernel. So technically, here you have a Linux kernel, okay? And technically here you can have a CentOS, here you can have root file system, Ubuntu, and here you can have a Red Hat, correct? Now,
Hmm.
got it?
Got yes.
Now, here you have Windows kernel, here you can have a Windows 2016, 17, 18. So it's like this. So always remember, image do not have a kernel. They share that from the host machine. And in a container, these four resources get created and they do not share these resources with other users. That is how it's become a application runtime environment and so on. Got it?
Yes.
Okay. So now the question is was what are the components you need to learn in order to become a Docker expert? So first thing you have to
Hmm.
install Docker. Okay, that is the first thing.
Hmm.
Then second thing
Okay.
you have to download the image. Just like that, you download the VM image, you will download the Docker image, and after that you create a container, and then container. I'll tell you the command for it, and then run the container. That's all. Work is
And
completed.
sir,
And
this Docker image maybe a vary. It's maybe a Windows. It may be a Linux, right?
yes, two structure, two architecture. No, Linux is different. See, all Linux has come from the Linux kernel. All Windows has come from the Windows kernel. So that is one. So when you say Ubuntu, CentOS, Fedora, Debian, these are the not a Linux. These are the root file system. This is the flavor actually. This is the flavor. Here they put it some tool. So for example, here they put it apt, and yum guys, I mean Red Hat guys, they put it yum. Simple.
Mm-hmm.
Yum was not there in the Linux kernel. Apt was not there in the Linux kernel. Correct now?
Right. It's a red hat.
Yeah. So like this. So now remember this. These are the four component you need to have it. So the question is, you have to install the Docker engine. You have to download the
Hmm.
image. But the question is from where? So this concept we call registry. Actually, this
Okay.
all registry concept is common, right? Docker registry. So there's one
Mm-hmm.
website which is popular, which is dockerhub.com, but there are plenty of it. Every cloud has their own public and private registry. You can create your own also. Your company will have their own registry also. So that's not a problem. Registry means what? Like a place where you have a image. For example, GitHub is a registry. What you have at the
Mm-hmm.
GitHub? Multiple Git repositories, right? So like that.
Right.
Okay, so these are the four few things you have to do that. So now,
Mm-hmm.
so step number one, install Docker. Simple. Install Docker. Step number two, download image. Step number three. Step number three. Okay. Step number three. Download image. What? Download image from registry, na? Correct. Registry. Hub. Typically we call it hub. Hub registry. Okay. And then what? What next? Then create a container. Create a container. Work with container, not create. Now little bit work with container. Now what can you do with the container? What can you do with the container? So typically, think very simple. What can you do the VM? So you can create a VM. After that you can start the VM, you can stop the VM, you can restart it or start it, whatever it is. Start the VM, you can restart it, you can pause the VM, you can unpause the VM. Correct, no?
Right,
Unpause
sir.
the, you can kill the VM, and you can delete the VM, remove the VM. Sorry. So same thing you can do with a container also. You can create a container, start the container, stop the container, start it back, restart it, pause it, unpause, kill it, and remove it. I'll teach you. I'll show you the demo. Now, after
Okay.
this step, these are the things what you have to do. So you got the containers working. What usually
Hmm.
you do? For example, you got a VM working. What you do? Connect to containers, right? You connect the VM, right? How do you
Right.
connect? You connect through SSH, or you
Yes.
connect through sorry, you connect through console. Console, forget about it. This is a container world. You should not talk with a console.
Okay.
Okay, so connect to a
Mm-hmm.
container and do whatever you want. These are the things.
Hmm.
Okay, or last thing, connect the container, and last thing, access the container from outside. Access a container from outside. Now why I'm saying from outside, because some containers has a web applications, so you can access from the network only, right?
Hmm.
So these are the five things you need to learn. Any
Okay.
questions?
No. And sir, in this containerization, where we are taking care of the network part.
Yeah. So let me put it in this way. So when, think simple, when you create a VM, where do you take
Mm-hmm.
up a network part? So there is a, let me show you, because context, if you set no, it'll be, so this is my hypervisor. Let it open and go to the setting, and here you have a multiple options. See here. Why is saying yes, yes, multiple time? Okay, come on. Hmm. So here you see these are the network options available. These are called driver. Oh, these are the called driver, bridge
Okay.
driver, NAT driver, internet host only. So these are the driver. These are the programs in which the networks. you have to use it. So typically, if you want to have it NAT or bridge to connect to your Wi-Fi, whatever it is, and NAT will create one network in your laptop itself. Host only it will share with the host IP address and so on. Correct now?
Hmm.
So these are the same options you will
Hmm.
have when you install Docker also. Remember, Docker will run containers. So containers should have a network, right? See here,
Hmm.
these are network, right? Each container will have
Right.
a network. So
Okay, means
this
network
container,
part is also separated in Dockerization. Means for each container have a separate network policy.
yes, network driver you can call it, right? So in the Docker, we have a three network driver installed, though you can install multiple extra add-ons, but one is bridge. Second one, bridge means, let me show you, correlate this one. It'll be easy for you. Now you must be, let's say if you don't know what is bridge, then that's the first assignment you should know what is bridge. Okay.
Okay.
So
Hmm.
yes, because these are the we have been using from last 20, 30 years actually. Okay. So here,
Hmm.
so if you see that these are the so many drivers are there, but in Docker we have a bridge default. That means by default, bridge means it will connect uh, to. It's like it will create a new network within your laptop. Okay, and NAT we have it. Okay, my bad. NAT we don't have it, and internal network host only network we have. I forgot one. So we have a bridge, we have host, bridge, host, and no network. Three. Yeah. So bridge, host, no network. So you see last one not attached. So these are the three options we have in the Docker. Okay. Okay. So coming back to the flow, these are the things we have to do. So now let's get started directly. So I'm going to create one machines quickly for demo, and this is a Docker Ubuntu. I'll go for it latest version. That's fine, and I'll go for medium. And here 18 30 GB should be okay. Remember, I have opened all the firewalls. Okay, just to avoid this, and the keys and launch. Okay, so now you here. I think I have so many applications. So Docker, this one. Okay, let's try this. Yeah. So this is my new machine. Instant summary. Let me putty, and here it is, and so on. So my demo will be little fast. If you think you're getting lost,
Hmm.
you can stop. Uh,
Okay. Hmm.
uh, Codings also you can slow down. Sometime I teach fast, sometime I teach slow, depends on my energy level. So that, okay, so I've connected this machine. Username is Ubuntu. Now you can become a root because Docker needs root or sudo, or there's one more condition. If you want to run Docker without root and without sudo, so add that user
Hmm.
in a Linux called Docker. But right now, I'll let me become a root.
So, sir, now
Okay,
you have just created simple uh, EC2 instance, right?
simple
This
EC2
is not
instance.
Docker.
No, I have to install Docker on it. No, So
Okay.
I need a one machine, right? I need a one machine
Mm-hmm.
where I can install. Got it? Just like you install the virtual box. Where you install? In your laptop. Correct now?
Mm-hmm.
So I have to
Right.
install this. I need a compute for this. Compute, network, storage, all this thing I need. Correct?
Hmm.
So now the question is, I got the VMs and I become a root. Now I need to install the Docker. How do we install it? Different platform, different instructions. I am having right now. So typically, whatever you are looking for the tutorial, start looking for this pattern. Whatever you are looking for it, at the end of it, put it at DevOps School. You will find my tutorials. So DevOps School install Docker install DevOps School, and here it is. I think this one will work for me. Okay. So now if you go this here, this command is for the fixed for a missing error. You don't need to follow. Here it is. This command. Okay. So let me run this. This will install. By the way, this all has come from the official documents. You can refer the official documents also, but just to save my time, I use my own
Mm-hmm.
notes.
So currently you're just updating that EC2 instance,
Yeah,
right?
yeah. Some repos will be created, updated, and then finally this command will do the magic. Last one. See if Docker C. That's the one. That's all. Okay, so done. Yes, should add y into that command and done. These are the keys. And this is the one command. Okay, don't mistake it.
Mm-hmm.
And and finally done. And then
Okay.
this
Mm.
one, last one. Okay, so this will basically install Docker.
Docker.
Done. So Docker is installed. How do we check it? So Docker has a architecture like this. Okay, so this is you human talk to Docker client. Docker client send the instruction to Docker D. That's a server running in your machine. Docker D will send to the container D, which is a container interface for the kernel, and then kernel. This is the whole flow. So I send a command using Docker to Docker D. Docker D send to the container D. Container D will talk to the kernel. Kernel D. Okay, so where's the Docker? So Docker client is this one. Where is a Docker D? Here. Where is a container D? Container D.
Mm-hmm.
Here.
Okay.
These all running. Grep. You can grep the process and Docker.
Hmm.
See here.
It's not
Run
running.
Docker.
Achha, okay,
Yeah,
spelling mistake was there.
yeah. I'm a
Hmm.
little fast in that. Okay, so running. Okay, so Docker is installed. Super. What is the first command you should run? So the first command is Docker info. Now, whether you understand this output or not, you should read few times. You get used to it. Okay, so community
Okay.
edition. This is the version, and rest of the things you should get it. Okay, info means everything about your system plus Docker. Now, see why this is done, right? But why we have come here, right? Why we have come here? To download images. So I want to check, do I have images already? So
Hmm.
Docker images, very simple command. Okay, Docker image,
Okay.
no images. You
Nothing.
see,
Hmm.
repository tag
Yes.
image ID. Now the question is from where we'll download. So go to the
Registry.
internet and, hmm, and spend at least half an hour here and register, create an account, just like a GitHub. Okay, be comfortable with it. Search. I just said spend as much time you want because this is the one place. It's like ocean of images. You'll find the lakhs of images here. Okay. Whatever the
Hmm.
images you can wish for, you will find it. Okay, any application, MySQL, Tomcat, Oracle, this, that, Microsoft, anything, whichever you can find it, Ubuntu, all these things. Okay, so here you have ocean of images. You can search. Let's say I search for HTTPD web applications. See here, so many, almost 10,000 results has come HTTPD. Now, so you must be wondering, okay, out of 10,000, which one I should use? Look at the download and pulls. Look at that whether it's verified or not verified. Okay, so verified. See here,
Hmm.
there's a multiple trusted one, because anyone can create an account image and upload to this place. Anyone. Okay,
Okay. Hmm.
so so it's like that. That's the reason I said you go ahead and create an account, register it, explore it, spend more time, look at the filtering, at least spend 30 minutes to get started. And anyways, you have to start from now. Okay, so what do we do? So I want to get the images from here, but let me tell you, there's so many other registries also there, AWS, Google, and stuff like that. So I don't have any images in my box. What do we do? Just pull these images. So how do we do it? Here
Okay.
it is. Commands and enter. One of the images I'm pulling it HTTPD, which is web-based application, web server basically. Look at this image is being pulled just like a Git repo is being pulled,
Hmm.
right? So now do we have images? Yes, we have images.
Yeah.
So this is also completed. This is also completed. Correct? Now we have to get the container. This is the flow.
Hmm.
Create, start, stop, start, restart, pause, unpause, kill, remove. Remember that. So what do we do? So before running this command, I want to know how many containers we have. Actually, there's none, but you should check. So Docker PS will tell you the running containers. I repeat, running container. If you want the stop
Okay.
container, created container, not running container, you should run hyphen A. A for all.
All.
Okay. So
Hmm.
these are the commands. Now what to do? So let's get follow this one. So let me create a container. Docker create command is very simple. See here, HTTPD. Sorry, there's a typo actually. HTTPD. See, container got created. Docker PS. No, because created, not running.
It's
See that?
off. Hmm.
Yeah. So container got created. Each container will get a unique 40 character hash value, which you see that shortcut and here. From image, container will run this inside a container. You'll run this command time created, and this each container will get a one random name generated by Docker. You can rename it also. Okay.
Hmm.
So now let me create one more container.
And sir,
This
what
time
is that port option and why it is blank?
I just name Rajesh. So I created one more container, but this time four containers total I created, and you see one I named it with Rajesh. Now
Hmm.
here port option. Remember that. Think simple. When you run VM, then only that IP address get allocated, right? Or port get
Hmm.
started, right? Correct now?
Hmm.
If
Hmm.
you stop the VM or if you stop the laptop, there's no meaning of port and network, correct now? Right? So now
Right.
this, huh, so this image, which is a HTTPD, is a web server, runs on 80 port, and IP address will be allocated by Docker. Okay, so that is
Hmm.
a how. So the moment you run it, you will see that port specifications actually. Got it?
No, sir. Can you please repeat this? Means,
Okay. See here, these are two VMs powered
huh?
off. Correct?
Yes. Hmm.
See that here. Do you have IP address for this? Do you have IP address for this VM? No.
Oh.
Correct now? You don't have IP address
Hmm.
for this.
Yes.
But if you start this VM,
Hmm.
then IP address will get attached, and the if any application is running in this VM will also get started, used.
Hmm.
So here same concept. Every image If it is a port based, let's say that, see, there are some image which is do not require port. For example, if you want to run Ubuntu, do you need a port? No. But if you want to run Apache, Tomcat, JBoss,
Hmm.
some port based network based application, for that you need a port, right?
Right.
So here, if you run this container, right now is created, not running. So port will be whichever that image has the port specification, it will start running with that port actually. I'll show you that in a few seconds. Okay.
Okay.
So now this is the created. Can I start now? Let me start this. So here, Docker start. I'm using my name Rajesh, and you see here.
Hmm.
See, now it's running. It's running on 80 port. Correct? Can I run this container also? Docker start, and you see that is also running 80 port only. So that means these two are isolated instance. Correct now?
Correct.
So like that. Now what is the IP address for this? So Docker
Hmm.
inspect container ID. See here. IP address is 03. What is the IP address of another one? Rajesh. It will be 02 actually, because first I created that one. So that is. Can you access it? Curl HTTP 80 port by default. See, you are able to access. 3. See, got it?
Okay. Hmm.
So this is the I did what? I did start it, but now I'm going to stop it. So Docker ps-a, just get a habit of it. So A means all. Okay. Now Docker stop. Remember that Rajesh container is running from the almost 1 minute and stopping it. I stopped the one container. See, exited. So when you stop the running container, the message will be exit. Remember, if it
Hmm.
has never run, the status will be created. Understand that way. Now what to do?
Okay.
I'm going to start it. Again, nothing great about it. Let me start this. Now it's running. Again, see, go up once again. Can I restart the first container? Restart means stop and start together. Restart. Sorry, here. See, my bad. Let me. Oh, why I'm running this? My keyboard is not moving fast. Huh. So see that restarted first one, 12 seconds.
Hmm. Correct.
So this is the one. Now, what is a pause? So let me first do the pause. Before that, I want to
Hmm.
run one command, Docker stats. So Docker stats commands will tell you which are the CPU, RAM, and network utilizations of your container. Right now, only two is running. Two was created only. Look at this. Each of this container. CPUs you are getting, memories, and stuff like that. And if you see that
Okay.
CPU is at least little bit of you are getting, and memory also little bit of it you are getting. Okay. So what is a
Hmm.
pause means? What is a pause means? So pause means containers will not get a CPU. Simple. So let me pause this. Docker pause. Let me pause the, both the container because this is not being used. So you'll not be able to see the maximum uses actually. So I'm pausing everything. I mean both running container. Look at this. Paused, paused. Now look at the stats. And if you look at the stats, CPU, look at the CPU, what do you say? CPU column.
Percentage.
Ha,
Hmm.
0.
Right.
So when you pause, CPU allocation stopped by kernel and only memories utilization will be there. So pause containers will not be accessible. You can pause it for the temporary, uh, workaround uh, to avoid the loss of data and then maybe troubleshooting or something like that. So I
Hmm.
just unpaused it and now it's running. Okay. Finally,
Okay.
kill. What is a kill? So kill means, see, it's like this. When you do the stop, it's a graceful way to shut down the containers. But when you
Mm-hmm.
call for a kill, it's like a merciless. That means just kill all the process of the container forcefully. Okay, so here
Mm-hmm.
going to kill one of the container, docker kill, and Rajesh, and you see here. Now look at this. When I stopped, and let me stop this container also. Let me show you the difference actually. When I stop and when I kill, what happens? You only see that. When I stopped graceful, the return code was 0. When I killed the container, the return code was one non-zero, 137. So that way, these both are the same, results will be same, but the method will be chosen whether gracefully or forcefully. Understood?
Yes, sir.
Okay, and last one, remove. You cannot remove the running container, but exited and created. So Docker rm means remove. I am removing one container and last container. Two container I removed and work is completed. So guys, this is your life cycle of the container.
Mm-hmm.
Any question on
Okay.
this?
No, sir, got it.
Okay. Now see,
Hmm.
containers you are running why? Because you want to connect or access it, right?
Hmm. Right.
What do we do? So I'll teach you how to go inside a container. So for that matter, Docker ps-a. Let me start both the
Hmm.
containers. So Docker start this container and this container. I'm starting both the containers. Now you see it's running. Now, now I want to go inside a container and explore it. So what do we
Mm-hmm.
do? Docker execute -it. So here, see, when you interact with the container, when human interact with the container, okay, let me be more generic. When human
And
interact
sir,
with the,
suppose in an organization there are multiple containers we have created, then how we can identify for which purpose we have created that container? Only by names, or there is any other
no,
options available?
basically whatever I'm teaching, is like
Okay.
alphabet of the container world. I repeat, alphabet.
Okay. Mm-hmm.
We have to learn Kubernetes also, which we run in the organizations. So that
Okay.
is somewhere here, somewhere uh, here.
Tenth
Container
number.
organization run in large. For example, I'm teaching you right now virtual box example, but you need to learn
Mm-hmm.
AWS also for production because virtual box is for the local only. Correct now?
Mm-hmm. Okay.
So
Huh.
like,
Mm-hmm.
okay, so I was doing something. Okay, so how human connect with the machine or compute? So using shell, right? Bash shell,
Right.
Corn shell, C shell, and something. So containers also is like an instance, right? Compute unit. So how do you connect? So you have to execute interactive way. Which container? So this container. But you have, if you want to execute, interact with it, how can you interact? So of course shell, right? So bin bash, which this executables you have inside this container, I know. And where are you? You are inside a container. See here, look at this prompt. This is my VM. This is inside a container. See here. This is your container file system, root file system. Got it? So how do you go inside a container? Simple. Okay.
Yeah. Hmm.
Okay. So
But every time, sir, we have to remember that container ID, right?
just give me 2 seconds.
Okay.
This conference will now be recorded.
Okay. So you're able to see my screen, right?
Ah, sir, yes.
Okay. So now, how can you connect it to container? So for that, you can use the exec.
Mm-hmm.
Execute in interactive way. What? Bin bash always has to be shell inside a container. Okay. And then you go
Okay.
inside a container and you can work like in a container just like you work in a Linux. Simple. Because it's a
Mm-hmm.
Linux container, right? So like that. Okay. So this is the way come out of it container using exit command. That's all. Now here I'm not happy with this so many commands actually. Create, I mean,
Okay.
but first pull, create, start, stop, all these things. So do we have any shortcut for it? So yes, there's a shortcut for it. What happens when you pull,
Hmm.
create, and start? These three
Hmm.
commands, you can combine it together with run command. So when you
Okay.
run, it will do the pull, create, start, and attached. Okay, what is attached? I'll
Hmm.
show you. When you do not want to attach to the container, hyphen D you add it. Hyphen D means
Okay.
detach, means
Hmm.
do not attach. So attach means what? So basically what happens, every containers has a one process, primary process. For example, any VMs, any compute, you have a first process. This is the first process, you see, right?
Hmm.
PID one. So what happens? Containers also has a PID one, their own process ID. Okay, so what happens when you run it, pull the image, create a new container, start that container, and get attached to the PID1, attached to PID1 of that particular container. And this PID1 can be anything. It can be shell, it can be Python, it can be Java, depends on the images actually. So if you look at this, what is the PID of my container? This is the PID actually. One. PID1. First process running in this container is HTTPD foreground. Okay. So now for that matter, can I run this? So look at here my screen. Docker run HTTPD. See here, I'm running this container, so it will do everything what I am stating here, but it will attach to the PID1. Enter. Where are you?
Okay.
So you basically lost your console and you attach to the PID1, which is HTTP foreground of new container. New, this created a new container, remember.
Hmm.
Okay.
Right.
If you want to see that from the duplicate session, because I lost this, so Ubuntu Docker hyphen and Docker
So
PS.
now
Okay,
we'll have a three container ID.
three containers, yes. And you see a Docker PS, see three containers. So now I will kill this container, Control C, and this container got killed also. Stopped means basically you stop the container. Okay, so now why we do hyphen D? Because we want to avoid that to getting inside. So this way, one container, two container, three container, four container. See the shortcuts and Docker PS. See, without getting inside a container, you are starting the container and so on. So why we use start? Sorry, why we use run? We know that, and why we use hyphen D with run? We know that.
Yes.
Okay,
This is
so
DFS. Yes.
most of the
But
time,
sir,
this
in run command, we don't have option to choose image, right?
yes, we have. I mean, we have a more than 1 lakh image on the registry. You
But
can
sir,
create your own image. So
but
I'll create a new container now. So here, look at my screen. I will create a new container. So what will happen? Docker run and some core images I will run. Okay. So for that, run hyphen
hmm,
D is there. IT also core images you have to run IT also. Okay. On Ubuntu. Look at this. This image was not there. It will be there, downloading. You see, pull is happening and create and start will happen
hmm,
again. So any
okay.
images. Okay. Any images you can
Hmm,
go and search for it. See that image Ubuntu. Now this image,
hmm,
this container, you can go inside this container, exec hyphen it. This is your Ubuntu image, Ubuntu container. Do whatever you want, just like Ubuntu. See, you are inside a container. See, oh sorry, what are the process running inside a container? PS. See here, only two process. PID1, look at this. PS hyphen
hmm,
EF. PS hyphen EF. I need a better keyboard actually. So you look at this bin bash. See, match this
right.
PID1.
Hmm,
Bin
correct.
bash and he bin bash.
Hmm,
Got it?
yes.
Yeah. So any containers you can create it, exit, come out of it. Okay. So that was the things. So this is the how to connect the container I taught you. Now, next thing is how to access a container from outside. This is important to understand. So let me tell you here first through the image. This is my VM which I'm using it. Okay, this my VM. This my VM which I'm using it. And remember, I'm outside of this VM somewhere, and this VM has a one public IP address,
Hmm.
and I'm connecting SSHing through this one. Correct? Agree?
Agree.
Yeah. So now, let me. There is one bridge is created here. When you install the Docker, no, automatically one bridge is created. So what is happening? Whenever whatever the container you create, this will get attached to this bridge, and the bridge. This bridge basically scope of this bridge is local only. Remember that, local only. Local only means this containers. Let me show you rather than so Docker PS. I have so many containers. Let's pick it up one and Docker inspect container ID. The IP address is this one. And if you want to container access the network of this container, you can access it because scope is local 8. See here. No. 8. See why it's not accessible.
Got to
Oh,
inspect.
sorry, my bad. This container is not a one to is one to not a HTTPD. So I have to use this different
HTTP.
container.
Okay.
Yeah, inspect. Yeah, 7. So let's go for 7 here. See,
Hmm.
I can access it,
Yes.
but this IP address will not work from my browser here.
Right.
Not It will not work for it. But because this IP address is local, scope is limited to the host only. Are you understanding?
Yeah, sir.
So what to do? See, the same thing we have to do what other worlds are doing. See, AWS also,
Hmm.
you have a private IP address and public IP address. Azure also
Right.
private
Huh.
IP address, public IP address. So this is your
We have
private IP
automated gateway.
address. Hmm. So now what to do? So you have to use this
Public
IP
IP
address,
and one
public IP
gateway.
address, and whenever you hit here with certain port, it should redirect to this container. So this here
Yes.
interface will do that things. So how do we create such containers? So you see this I've been doing run -d httpd. This I've been doing, and it will results in the container which is not exposed outside, not linked with outside. See that? But this time I will do little different. I will say, hey, I want to expose the port from outside also. So P, this is the external port. This is internal port. Remember, internal port will never change because Apache is running by default on HTTPD. Port you can use it of the host machine port. Host means this port 80, 81, 82. So here 80 got attached to this one, 81 will attach to the another port, another container, 82 will get attached to another container like this. See here. One, I'm going to change 81. See two container, Docker PS. Look at this. See, so if I
Hmm.
hit 80 IP address and 81, it will take me to one and second container. Let me show you. So now if I use IP address 80, enter this first container, and 81, this is a second container. So
Okay.
what we did,
Yes.
basically we run and expose using this one -p. Got
Okay.
it?
Hmm.
Okay. So this is the
But sir,
one.
here we have not attached any IP address. We just change the port number, right? Means first we it go to the
Attach IP address means
81.
host IP address. Host IP address. Automatically it's running in this host, no? So you cannot be other IP address than this host, correct?
Right. Yes. Yes. I forgot that thing. We have created
Yeah.
Docker on one host. Hmm.
Yeah, but you can attach to the IP address of AWS also. I mean, there's a way. I'll not complicate this discussion. Kubernetes and all, lots of concepts are there. You are just learning the alphabet of container world actually. So many things are there. But most of the concept of Linux with physical server, VM server, or container, almost same. 99% same. Okay. So guys, this is the one where I taught you what is Docker, what is container, what are the components of containers, how Docker works, what are the things to get started with the Docker, and some of the important commands and so on. Okay, so now this is the history of my commands which I learned, which I run, and plus this almost 20-30 commands I taught you. So you have to this one also I run and all. So now you have to practice this one, and once you get comfortable with the containers, then I'll teach you the most important question topic, and which is how to develop your own images. Okay,
Okay.
so how to develop your own images. So here, uh, let me tell you, Docker commands, DevOps school. So learn in this flow. Okay, all the commands you cover. The first command, working with containers, which I covered just now. Then monitoring containers, working with image. This is the next topic. I'll teach you how to develop your own image and so on. Okay, so some of the URLs reference, just a second, hold on. Reference I use in this training is this one and this one. And I would like to show you something more. Docker architecture. Arch, archi, Docker, just put it up, it'll be easy. And some lots of tutorials we have, but I got so many. What is Docker? What is Docker? And this is the one. And this is the one. And architecture actually I want. Architecture. Yeah, this one. So yeah, these are the things you can
Okay.
refer. Now, this is something which I said. Now I'm going to create. I'm going to share with you these notes, and next sessions we are going to learn the images. So tomorrow I'm going to teach you how to create an image, and meanwhile you have
Okay.
plenty of time. Say practice it 2 to 3 hours, same thing,
Mhm.
and